So yeah, there's the membrane that keeps it waterproof, gets gases to the NDIR sensor, which I'll talk about shortly. And because you're measuring gases in the vapor that's adjacent to the water, using some very fundamental chemistry, if you know the concentration immediately adjacent to the water and the vapor, you can easily calculate what the concentrations are in the water. And these things most of them are battery powered. We've got them at a lot of active sites, so they need to go down in a flush mount so people can drive over them. So in that case, the batteries fit in there. In cases where it's maybe not such an active site, you can have stick-ups to have them be solar powered. They can also be directly tied into a power source on site. Usually they measure every 30 minutes to half hour. And yeah, it's automated data collection. So this is the not so secret sauce, the NDIR sensor. So really, this is the same technology that would be in your carbon monoxide or dioxide detector at home. So in this case, we've got this sampling tube, we've got an emitter and a detector. And what this does is gas is able to come in. Really, these are both inlets and outlets. We've got a highly reflective tube that, in our cases, they're gold plated to allow lots of light to make it through. And this is a 2-channel example where we've got an infrared active light source. Let's say it's tuned to carbon dioxide to keep the detector, the home detector analogy going. It's going to emit a wavelength of light that it's 100% here, and it's diminished by the time it gets to the detector. And that reduction in the intensity is due to carbon dioxide. And so to get the robust estimates, you also have an IR source that's close to the same wavelength, but is transparent to carbon dioxide. So it makes it all the way through. And so you compare how much of your active filter made it through relative to your reference filter. And that difference, essentially, it's overly reductive. That gives you your gas concentrations.